Hello, this is Mrs. Dowell, and I would like to show you how to use synthetic division to test possible rational roots. Please notice that the rational roots that we are going to test are listed in the top left corner of the screen. And I would like to demonstrate to you how you can use synthetic division in order to test possible roots to see if you end up with a factor. But you need to know how to set up the synthetic division. You take each of the coefficients of the decreasing powers. You must have a place for each one of the powers. So if you are missing a power, then you would need to put a 0 in as a placeholder. So this is 1x to the 4th minus 3x to the 3rd minus 8x squared plus 12x plus 16, which is our constant. If I'm going to test number 1, my goal is to get a remainder of 0. If I get a remainder of 0, then that means that what I just multiplied by was a rational root. So the process of synthetic division works this way. And I do it a little differently than the way the text does it. So you can follow along. I drop this first number down. I take this number. 1 times 1 is 1. Add down. 1 times negative 2 is negative 2. Add down. 1 times negative 10 is negative 10. Add down. 1 times 2 is 2. Add down. This is not a remainder of 0, which means that 1 is not a root. Now I shall try negative 1. Okay. Drop the first number down twice. Negative 1 times 1 is negative 1. Add down. Negative 1 times 4 is positive 4. Add down. Negative 1 times negative 4 is positive 4. Add down. Negative 1 times 16 is negative 16. Add down. Hooray! That means that negative 1 is a root. A root occurs when the remainder is 0. If negative 1 is a root, then that means that x plus 1 is a factor. There is a difference between roots and factors. So if these are the 4 possible rational roots that came from my 4th degree polynomial, all of my factors look like this. Okay. Now, in the process of doing synthetic division, what I'm left with right here is called a depressed equation. This is called a depressed equation. So what is this equation? Well, this 1 up here was 1x to the 4th minus 3x to the 3rd. See, this was 1x to the 4th, 3x to the 3rd, 8x squared, 12x, and 16. So in my depressed equation, all of these powers are reduced by 1. So this is 1x to the 3rd minus 4x squared minus 4x to the 1 plus 16. Okay. From here, I still need to find another root? Well, once you get down to the third degree, oftentimes you can just simply use grouping, or you can do synthetic division again. So I'm going to see if I can use grouping in order to factor this. 1x to the third minus 4x squared minus 4x plus 16. The greatest common factor here is x squared. That leaves me with an x minus 4. The greatest common factor here is negative 4. That leaves me with an x minus 4. I'm very happy because this means that this problem is a factor by grouping problem, which means that I do not have to do synthetic division again. You've already learned how to do factor by grouping. So this depressed equation factored by grouping into these two factors. So this was a factor, this is a factor, and this is a factor. I would, however, like to point out to you that x squared minus 4 is, in and of itself, a difference of two squares and can therefore be factored further. So x squared minus 4 would be factored into x plus 2 and x minus 2. Then I'm going to list out all of my factors. Okay, so I have, in the process of using the rational root theorem, listed possible rational roots. I tested only 2, but if I wanted to test 2 or 4, I would see that that would work also. In fact, I'm going to do that on another slide for an individual example of how to do synthetic division. Okay? This is my constant. So the process is like this. 2 times 1 is 2. Add down. 2 times negative 1 is negative 2. Add down. 2 times negative 10 is negative 20. Add down. 2 times 8 is negative 16. Add down. So I have another depressed equation because I ended up with a remainder of 0. That means that 2 is also a root. So far I have negative 1 was a root, and I have 2 was a root. My depressed equation in this situation would look like this. 1x to the third minus 1x squared minus 10x minus 8. That is my depressed equation.